Welcome to Olympian Water Testing, giving you the best in water analysis. Today we're looking at the NIH, National Library of Medicine, and a study, the Ecotoxicology of Hexavalent Chromium in freshwater fish, and they're taking a review and seeing what this does. So chromium CR is a naturally occurring element found in rocks, animals, plants, and soil, predominantly in insoluble trivalent form, and that's also known as chromium-3. There's different types of chromium, chromium-0, 3, which can actually be beneficial, and 6. An intense industrialization and other anthropogenic activities have led to the global occurrence of soluble 6, which is readily leached from soil to groundwater or surface water in concentrations above permissible levels. And the toxicology of 6 is linked to environmental persistence and the ability to induce a variety of adverse effects in biological systems. And that includes fish, the fish we eat. And heavy metals are not all the same. The two we want to watch out that really affect fish are methylmercury, coming from mercury, and also chromium-6, because that can cause problems for our aquatic creatures and in turn our ecosystems. In aquatic ecosystems, CR6 exposure poses a significant threat to aquatic life, and it reviews the transport of CR6 in the environment and its acute chronic effects on fish, and also the toxicity at a cellular, biochemical, and genetic level. So what did they find, and what are they looking at? Pollution by heavy metals has become a serious environmental and public health hazard because the concentrations released into the environment from industrial process often exceed permissible levels, and due to bioaccumulation and non-biodegradable properties, heavy metals constitute a core group of aquatic pollutants. Their high toxicity, even low concentrations, can produce cumulative deleterious effects in a wide range of fish and other aquatic organisms. And chromium is one of the most common and ubiquitous pollutants in the environment and does not occur naturally in its pure metallic form. It is present in 3 and it is present in other forms, but 6 is oxidation stress, and with 2 and 3 being the most stable forms, chromium enters a various environmental matrices, air, water, soil, from a wide array of nature and anthropogenic sources, and then the health hazards associated to exposure with CR are dependent on its oxidation state. Hexavalent chromium, and that's chromium-6, is a toxic industrial pollutant. So 3 is more naturally occurring, 6 comes from the industry that we engage in, heavy industry. And as a classified carcinogen possessing mutagenic and teragenic properties, and all chromium-6 containing compounds were once thought to be man-made, with only 3 being naturally ubiquitous in the air, soil, and water. However, naturally occurring CR has been found in the ground and surface waters at exceeding levels, and the WHO has a limit for drinking water as well. Now, what does it specifically do to aquatic life? Well, generally, the aquatic environment is the ultimate sink for metal pollutants, and that's part of the issue. That's why there's so many heavy metals in fish, and it also affects our water. Several industrial applications like leather tanning, electroplating, corrosion protection contaminate groundwater, whereas surface waters are polluted by discharge from manufacturing processes and cooling towers. On the other hand, the combustion of fossil fuels, manufacturing, processing of iron and steel release CR into the atmosphere. Most of the CR in the air eventually ends up in the water or the soil, and when released to land, CR compounds to bind soil and is not likely to migrate to the groundwater. In water, however, these compounds are very persistent as sediments with high potential for accumulation of CR in aquatic life. In its dissolved form, CR is present either in anonic trivalent or hexavalent. And interest in the field of toxicology, fundamental research on the impact of toxic chemicals on terrestrial, freshwater, and marine ecosystems at the population and community level has undergone a strong surge in aquatic systems. Several recently published reports have linked the occurrence of anomalies in various fish at psychological, histological, and biochemical, enzymatic, and genetic levels to toxic effects of CR6 and many chromium-6 exposed fish. Certain species have demonstrated extra sensitivity, whereas others are tolerant. So some can tolerate it, but that doesn't mean it's not affecting a lot of the fish population. And more in-depth studies in toxodynamics and toxokinetics are needed. However, to establish an exact cause-effect relation, the scientific data is discussed in this review provides a basis for understanding the potential impact and for advancing our knowledge of exotoxicological effects and the assessment of CR. And we can see that chromium toxicity to fish is an issue. It depends on the biotic and antibiotic factors, and they include the type of species, age, and development stage, and the temperature, concentration of the CR, oxidation, pH, alkalinity, salinity, and moreover lethal and sublethal concentrations of it as well. We can see the different fish species right here, how the exposure affects them, the pH, and we can also see what happens there. That being said, though, there's a lot of fish that are being affected. Effects on fertilization, decrease in blood clotting in time, increase in different types of activity, decreased antibody, decrease in ion-dependent ATP activity, decrease in glycogen, decrease in issues total protein content of liver, muscle, and gill, reduction in the liver glycogen, hyperglycemic response, and decrease in cell viability. So there's a lot of issues that happen to fish. So chromium-6 is something to definitely be aware of. And it's always a good idea to periodically test our waters to make sure there's not elevated levels of chromium-6, for the effects that they have on our aquatic ecosystem will eventually be the effects that they have on us.